Welcome all. You're listening to the MLTI podcast, Teaching with Tech.
We are your hosts, the MLTI Ambassador Team at the Maine Department of Education.
We are here to support Maine educators by building a network focused on authentic voices, experiences, and technology integration.
Hello and welcome to the MLTI podcast, Teaching with Tech. My name is Chris Beckwith and I will be your host for this, our second November podcast. In our last episode, we dove into the topic of computational thinking, defining it and realizing that not only can the process be applied to content areas across the curriculum, but that it can be such a natural process you may already have been practicing it. Later in this episode, MLTI Ambassador Josh Schmidt will do a few laps in the pool with Jeff Bailey, with an interview that will reveal some of the real-world applications of computational thinking that Jeff has explored with his students. But before we embark, I'd like to remind our listeners of this year's MLTI student conferences. We will be hosting 2 student conferences again this year, one virtual and one in person. If you've attended the in-person conference in the past, you know you're in for a tech-tastic day of fun and learning. But if you're planning to participate in the virtual conference, we're shaking things up this year, and we believe you're in for a welcome surprise. The virtual conference will be on March 7th, and the in-person conference will be on May 23rd. You can always find the link in the show notes or email us at doe-ltt@maine.gov. At this point, I'd like to introduce my co-hosts and fellow MLTI ambassadors AJ and Yuhong. Welcome to the podcast. Would you both please tell the audience a little about yourselves?
Thanks, Chris. I'm glad to be here. My name is AJ Rogg. I'm a first-year ambassador, and before that I was teaching in Portland at Lyman Moore Middle School, and I've been teaching for about 28 years.
Hello, I'm Yuhong Sun. I'm one of the second-year MLTI ambassadors. Prior to this, I was a computer science teacher and a Chinese language teacher at Noble High School for 18 years. The computer courses I taught include web development, web animation, Cisco networking, introduction to programming language, and AP computer science.
Yuhong, it sounds like you have a lot of experience teaching computational thinking. Can you give us some ideas of how you introduce the concept of computational thinking to your students? And perhaps maybe give us a couple of examples that you've taught?
Sure. Computational thinking is just a fancy expression. As a matter of fact, it is what we use in our daily life. Take decomposition, for example. It involves breaking down complex tasks into smaller, more manageable parts, which can be applied to many things, such as cooking a meal, organizing tasks, learning new skills, etc. When I taught decomposition, for example, I like to start out with an analogy of planning a party. I broke down the tasks that were involved into smaller parts, such as sending out invitations, planning the menu, organizing entertainment, etc., to show my students how breaking down a complex task into smaller, manageable parts could make the overall process easier and more manageable.
I think that's awesome, Yuhong. I see that you take that concept way before you even have the kids touch a computer, and I think that's kind of a really interesting and profound way of teaching computational thinking before even having the kids get on the computers. It's about teaching them an approach that's useful in a bunch of different situations. So can you tell us a little bit how you might transition from using these everyday life examples unplugged to your computer science concepts?
Sure. Transitioning from using everyday life examples to computer science concepts was a natural progression in my teaching approach. After illustrating the concept of decomposition by using the relatable example like planning a party, I continued to apply decomposition into my lessons. I broke down programming language concepts into their basic components. For instance, when teaching loops in Java, I divided them into while loops, do-while loops, and for loops to show my students how these structures operate within the language. This transition allowed me to demonstrate how the principle of decomposition could be directly applied to programming language. By bridging the gap between everyday experiences and computer science concepts, I tried to make learning more fun and engaging for my students.
So I'm curious, Yuhong, how did your students respond to your approach of breaking problems down, decomposing them into smaller, more manageable parts? How did they improve their ability to write code, solve problems as a result of incorporating that idea of decomposition into your lessons?
My students responded to my approach very well. They found it helpful in understanding the fundamental concepts of programming and were able to apply this knowledge to solve problems. As a result of incorporating decomposition into my lessons, I saw significant improvements in their ability to write code and solve programming problems. They also become more organized and efficient not only in their programming practices, but also in solving more complex problems and facing more advanced challenges in other situations.
While I think the how and the why of CT are important, I think that CT is best utilized when it is applied to real-world problem solving. Our fellow ambassador, Joshua Schmidt, had an opportunity to interview Jeff Bailey, computer science teacher at Mount Valley High School in Rumford, Maine. Let's take a listen to what Jeff has to say about CT as it applies to real-world problem solving. Maybe afterwards we can each share our own examples.
Well, thank you so much. I'm joined today by Jeff Bailey, who's going to talk a little bit more about computational thinking and specifically the role that computational thinking can help us to solve real-world problems. But before we dive in too hard, Jeff, can you introduce yourself a little bit, talk about the role that you have in your school?
Yeah, I'm Jeff Bailey. I teach technology electives, including computer science and another class called Make a Difference Lab at Mountain Valley High School in Rumford, Maine. It's a pretty small school, about 400 kids, 9 through 12. And I work with a variety of kids from different levels, all the way from advanced placement level students and dual enrollment college course students. And then I also work with students with special needs as well, and then some general electives in between. So I really like working with that variety of student levels, abilities, and interests.
Well, and pulling back the curtain a little bit, you were actually the person who first introduced me to computational thinking when I was doing my master's program. And I felt like the way that you talked about it made it feel extremely valuable, but also accessible. And I think that's a part that's really great, you know, in the context of this. And we had talked about that before we hit recording today. But I just wanted to kind of get your read on, like, how did you first start, you know, exploring computational thinking? And then what parts of it really stood out to you as valuable?
As I started to learn some basic coding and programming, and I mean fairly basic stuff, even though I teach some of these classes, I don't at all consider myself to be a coding expert or a programmer. As I started to learn some of those methods of best practice for teaching computer science, I kept seeing that computational thinking skills seem to repeat throughout what, you know, no matter which coding environment you were doing, there are some basic overarching skills that you're sort of reinforcing with students. And those skills transcend just the computer science domain. So prior to being a technology teacher, I was an English teacher for 10 years at the same school that I work at. And so I started to see some really interesting overlaps between what was sort of branded as a new concept with other terminology, right? So critical thinking, design thinking, inquiry-based, scientific method. And I actually found ways that computational thinking can be utilized as a thinking skill, as a teaching skill, a way to learn something that could be totally separate in some ways from, certainly from programming and coding, but even from the larger area of computer science. And those are all things that we teach, right? We all teach like a series of steps to solve a math problem. We all look at a historical event and try to figure out what are the key moments that led to those results. And I would say too that one thing that happens with computational thinking is that people believe that it has to be that you have to think like a computer. And I would actually argue that's reversed. You have to understand how the computer works, but you're trying to get the computer to think like a human being would think. Because some people think computational thinking is how you turn people into robots, essentially, thinking, crunching numbers in the way that a computer would, where what we're trying to do is use the power of computing to extend our own thinking and skills and knowledge.
When you were first describing it to me, that really helped me understand it is kind of just what you talked about there, that not only is it already in use in all of these other aspects of education, especially if you are someone who's a project-based, problem-based focused teacher, or just trying to work with real-world problems. I think that there's this power in solving real problems using a method that is actually useful in solving these problems. And so I kind of wanted to transition a little bit. At Actum, you did a session specifically talking about using computer science and, by extension, computational thinking to solve real problems. And you've talked about this a little bit as well with why that focus matters to you. But can you just talk a little bit about that session, the problem that you were identifying that you had solved with your students, and why that makes a difference when you're constructing content, focusing on the problem, making sure it's an actual real-world problem you're solving?
Yeah, so at Actum this year, I presented a session on solving real-world problems using computational thinking. And to zoom in a little bit, we had an excellent workshop from the Maine Math and Science Alliance that came to our school. And Pam Buffington and Ian Collins came from that organization. And they had, Ian led a session dealing with microbits, which I have in my classroom. They're very small, programmable little microcomputers. Are about $50 or so, and they have all these sensors on them and this LED display, and it can play noises. And it seems a little bit like a toy when you first get it. It's got a B button like a game controller. But the number of sensors that are on this thing allow you to do some really powerful things, and they're very easy to code. I really am driven when I get kids to have a real audience or a real purpose that's beyond just passing something in for an assignment for me, because it has a built-in motivation when I can say, all right, kids, this is not for Mr. Bailey. This is not, yes, you're going to get a grade, but it's really not for me. We're trying to solve a problem for someone else, a real problem, right? So it's intrinsically motivating when you do that. So the problem that I tried to come up with was, Ian had an example where, can you make an alarm for someone trying to steal from the cookie jar in the kitchen, right? With this microbit, because it's got light sensors and sound. So that was pretty clever. And I was like, oh, that's really cool. So I'm like, well, what's a problem that we deal with at my high school, right? And I don't think this is unique, but like sometimes kids linger too long in the bathroom. Sometimes they are trying to avoid class. Sometimes they might be, using vape devices and shouldn't be, sometimes there's vandalism, right? Sometimes there's just socialization happening, right? So I wrote a problem statement and I brought it to my introduction computer science kids. And I said, here's the problem we have to solve, right? And for that class, because I cover more than just coding, that's how I introduced coding to them. Computer science and programming and coding, that part is best used and learned when applying it to a real problem or a problem you're trying to solve, right? Computer scientists don't just sit around doing code for no reason, right? So I said, okay, we're going to use these devices and we're going to see what we can do. What ideas can you prototype and come up with that might help solve this problem? And what's great is you get a variety of solutions, right? Yes, I had some kids that just coded essentially a timer with an alarm that goes off, right? But then I had other students that said, well, what about using the light sensor? We happen to have automatic lighting in those bathrooms. So when you walk in, the motion lights go on. And they said, well, what if we use that as an indicator that someone has entered the bathroom, and then use the light sensor as a trigger for the code, right? So now it will only do this timer if the light turns on. So if I can say to kids, what are the important things, right? What do we need to focus on? And then how do we do those things piece by piece? What are some patterns we can follow? Are there some examples, right? Those types of things. Those are the types of things I think teachers are already doing in a lot of ways. They just didn't call it computational thinking.
Do you feel like teaching, like if we focus on like the microbit itself, do you feel like you had students who maybe learned more or like a varied skill set? Because when they're trying to solve a problem, it's probably a little bit different than saying, all right, we're going to do 5 steps on learning the microbit. We're going to learn to set up the code. We're going to learn what the light sensor does. We're going to learn what the sound sensor does. The students probably came to you and said, I want to do this. How do I accomplish that goal? And I can just imagine that being they ended up learning more about the process. Do you feel like that was a benefit? And did you see any other benefits like teaching it in this fashion?
Yeah, because I didn't say we're all going to make a sound sensor that beeps after 5 minutes. Kids have more choice in what they do, so their motivation is heightened. B, there's also this sense sometimes, particularly with high school students, I find, but probably is present at other age levels, of doing just enough to get a grade and be done. So I'm certain that I have kids do more independent investigation, collaboration, because I also say you can pair up with a partner for this. And I think those, it lets me get around the classroom and see what each kid's idea is. And quite frankly, there are problems they point out to me that I can't solve. They'll say, well, how do I get it to do that? And I say, well, I don't know, but let's see, what do you think it's closest to, right? There's a whole bunch of resources on their website. Sometimes they don't get choices to do something in a different way. And that's why project-based classrooms have that advantage, I think, that kids can make some choices. It's okay to fail and try something different. And then you're just always approaching that problem that you're trying to solve for.
Well, I really appreciate you giving us some time today, and I am constantly reminded that I feel like the way that you speak about computational thinking makes it feel really accessible, but also valuable. Like it doesn't need to be simplified or dumbed down to be something that is really intrinsically beneficial within a problem-based setup. I just wanted to close today's interview with kind of asking you, thinking forward, are there some maybe future real world problems that you're excited to try and solve with your students? Maybe some strategies that you're really thinking about, giving a test in the future?
The other class that I teach that is not specifically a computer science class is called Make a Difference Lab. And its goal is to try and solve real problems using technology tools along the way. We are thinking about different problems we see in our school and community, and then where I'm trying to find a technology tool I think would be a good fit. So we've done some things like that. I would like to do more of trying to get kids to solve for problems in other subject areas. I think there's a ton of stuff we can be doing with certainly STEM classes, but not just that. We have a laser cutter engraver that we have access to in my classroom. And so doing some really cool art collaboration. So I look forward to doing some things like maybe, build some apps for local businesses, or, maybe study helper apps that we could build for other classes. I like to point out to kids that I think it's Quizlet was designed by like a high school student. Yeah, it was designed by like a high school junior or senior, and then he went to college, and I'm sure he's doing very well. Those are real things, right? That people were able to do, and it wouldn't take much for people to just get an interest, find a problem that they want to solve, and then find the right technology tool or process. Even doesn't even have to be a tech tool, but a process for how you go about solving it.
Thank you so much. This was incredibly valuable. I'm sure you and I are going to talk more about this in the future, but we really appreciate your time and have a fantastic rest of your day.
Thank you.
Wow, another great interview here on the Teaching with Tech podcast. AJ, have you had any personal experiences with using computational thinking to solve real-world problems?
Actually, I have. Before I go into that, I heard two things that Jeff was talking about, and one was going to conferences, and I thought that was a really poignant piece that I think teachers really need to get themselves to some of these conferences and hear what's going on out in Maine and what teachers are teaching. But on the other piece is also to celebrate what they're doing. I think we need to really boost these teachers up for what amazing things they're doing and give them the confidence to bring some of those things to other teachers in the state.
I totally agree.
But on my part, teaching computer science, the biggest real world piece that I've done is creating apps. So I had the kids create apps that could do one of two things. It would either help them through their middle school life, which is a complicated part of growing up. So what's something about getting through middle school that an app could help you with? And if they couldn't go there, another piece was how could it help somebody else? And I guess I had two pretty amazing ideas that kids came up with. I mean, I had a lot of kids do the homework helper or something like that, but two that I thought were really amazing were one was an outfit designer. So kids had created an app where they cataloged all of their clothes in their closet, and they could pick the weather for that day or a certain color style and hit a button, and it would create an outfit for them for that day, so they wouldn't have to spend hours trying to figure out what to wear. So that was a really cool idea that would help kids make decisions quicker about what they're wearing for a specific day. And then the second one was more like real world out beyond middle school. Was a UV. Actually, it was what was the name of it? I think it was called a sunscreen checker. So it was an app that would allow someone to put in where they're going to lay out on the beach or go outside, and it would check the city they're in, the UV index for that day, the temperature, and then it would tell them pretty much what's the best SPF to use, and then give them a reapplying time, almost like an alarm clock that would tell them when to reapply.
Well, maybe I can borrow that student app. It helps me pick my outfits in the morning because I know sometimes my wife questions my choices.
That's funny. Those are two examples, but creating an app was kind of that catalyst to a real world problem, because we know that we all have apps on our phone that help us with real world issues that we're having, and we all try to find ones that make life easier. So to me, that was kind of the perfect example of how to use computer science, computational thinking, real world concepts. Yuhong, do you have some examples or things that you've done in your classes?
I began to incorporate computational thinking into my curriculum in the 2018 and 2019 school year. In my introduction to programming language class, students used their computer science knowledge and skills to create a website called We Care to fight against suicide. On the website, they embedded an online chat room and messaging. Their mission was to create a safe platform for students who suffer from mental illness to tell their stories, share their struggles, and get help. In the project, they used their computational thinking skills to break down the tasks into smaller parts, designed algorithms, solved their problems, and finished their tasks on time.
Those are some amazing examples, Yuhong. Definitely high impact. I recall in our last episode that we mentioned how many educators might be afraid to implement computational thinking because they feel it is purely rooted in computer science. So Yuhong, what advice would you give to teachers who might be feeling this way?
The misconception that computational thinking is only about computers and computer science can be indeed intimidating for teachers. In my opinion, for teachers to effectively teach computational thinking, they need to have a solid understanding of its principles. This includes being familiar with problem-solving strategies, algorithm thought process, and logical reasoning. These are fundamental aspects of computational thinking and can be applied to various subjects and disciplines. Additionally, teachers should possess the knowledge and the skills to integrate computational thinking into different subjects, creating engaging activities and projects that promote computational thinking skills. This might involve using everyday life examples and analogies to illustrate computational thinking concepts, making learning more relatable and accessible to students. Furthermore, teachers should be able to provide guidance and support to students as they develop their computational thinking skills, offering feedback and encouragement along the way. By fostering a supportive learning environment, teachers can help students build confidence in their computational thinking abilities and see its relevance beyond computer science.
Yes, absolutely. I've been reading an article about some of the actual uses, practical uses of computational thinking, and some of them I would never have thought of these examples, like the medical industry using computational thinking for diagnosing, for analyzing images and identifying patterns in patient data, and I know they're using AI with a lot of that now, which is going to lead us into future podcast episodes. Something very relevant for Maine in particular, agriculture and farming, where they're using the computational thinking to help them with making decisions about planting, about crop rotation, managing herds and disease control. For meteorology, analyzing complex algorithms for weather patterns is an application. In criminology, that forensic investigations are all about computational thinking. And in Maine and across the country, environmental concerns with distribution of renewable energy and managing wildlife populations.
So Chris, I look at what you just talked about in the articles you read, and all of those things that you have are not typical computer science topics. So these are topics that you're going to see in social studies class or health class, or in high school you might have a criminology class, or so that those are really just perfect examples of how way beyond computer science this concept of computational thinking is needed and used.
Yeah, absolutely. And that's I think the most important thing we can be doing in schools is providing them skills for what comes after.
Absolutely. So yeah, thank you for those. I didn't even know those industries were using that. That's amazing.
Chris and AJ, I want to thank you for having me on the episode of the Teach with Tech podcast. I really enjoyed talking about computational thinking with you both. Thank you.
Well, I'm really happy that we were able to focus our conversation today on how CT can be used to solve real-world problems. This approach can help to up student engagement and make the learning truly impactful for our kids. Thanks to my co-hosts AJ and Yuhong, and to Jeff Bailey for taking the time to share with us his knowledge and experience with CT. Please join us for our next episode where we will further our discussion around artificial intelligence and how it can be used in schools. Speaking of that, we would like to share an upcoming event dedicated to AI in education. The Elevation Summit will be held on January 13th, that's a Saturday, at South Portland High School. This event is co-sponsored by Actum and Meta. Amanda Fox, author of The AI Classroom, will be the featured keynote speaker, and attendees will get a complimentary copy of the book. Attendees can also be part of a book study on the AI Classroom that will be co-facilitated by Amanda and the MLTI ambassadors. Spaces are limited to 150, so make sure you go to actem.org and sign up if you would like to attend. As always, we want to hear from you as well. Whether you know a great educator doing something awesome with AI in their classroom or are just curious how the team can support you and your school, please contact the MLTI and LTT teams at the Maine Department of Education by emailing us at doe-ltt@maine.gov. And remember, if your USB Type A cable doesn't fit, just keep turning it over repeatedly. It always takes at least 3 attempts. Stay toasty. Class dismissed.